All right, this is talking about a histogram. Now remember what we talked about in class. It's looking for a kid who has a score of 62. So now what we're going to do is this. Let me go ahead and change the color on this. All right, so remember the score is 62. So what it's asking for is for you to calculate the percentile. Again, here's the kid. He's at a 62. It says in the first sentence that 33 or more than him. Therefore, that accounts for 34 kids. If there's 78, you subtract the 34. Therefore, you have 44 kids that this person scored higher than. So therefore, 44 out of 78, which is this ratio right here, gives you a 56.4% percentile or 56th percentile. When you convert it to a z-score, you basically x minus x bar over standard deviation. Here's your x, that's the score of a 62. Your average, standard deviation, gives you a z-score of 0.42, and what that means is that if this was 0 and this is 1, 0.42 is going to be somewhere around here. All right, so now what's going to happen is you have to calculate, or you have to interpret this, and this is what I wrote. This part right here, he scored higher than 56% of the 78 third graders on the self-assessment. So you're reiterating what it's talking about. And then you're telling me that a z-score of 0.42 means that his score is above average. Now, when it talks about a typical self-concept score, typical refers to the center. Like, what's the average score? In this case, because it's skewed data, you're going to use the median. And the reasoning behind this is the typical score would be a 59, which is the median, since the data is skewed. Skewed data affects the average more, therefore we will use the median and the 5-number summary to describe the data. But again, typical refers to the center, and in this case it's the median. All right, question number 2 deals with a cumulative relative frequency graph. Now remember, cumulative relative frequency is 100%. So this side right here deals with 100%. So Q3 is 75, Q1 is 25%, and your median is 50%. So you have to calculate those. Well, the median, if you take your median at 50%, calculate it right here, go all the way over to your graph, and then come straight down. You can approximate it. It's not quite halfway, so you could say 3.3 or 3.4. In this case, actually, it's almost a 4. So we stated it is approximately 3.8 minutes. Now the IQR, again, it's Q3 minus Q1. You're going to draw a line straight across and down to get Q3, which is about 4.8. Straight across for 25% and straight down, which is about 3.4. Subtract Q3 minus Q1, and you get approximately 1.4 minutes. And there's always some room for just the way you draw your lines and so forth. So it'd probably be between 1.2, maybe up to 1.5, or even 1.4, depending on how you draw your lines. And that's how you show your work, is by drawing the lines. Now, on question B, it says, according to the data, basically what it's asking you to do in this case, it gives you the mean, it gives you the average here, and then gives you the standard deviation here. Well, what it's asking you to do is add 5 seconds to the end of each song. Then it's wanting you to convert it to to seconds. So basically, you're going to be multiplying by 60 and adding 5. Well, remember when we talked about transformations, multiplying only affects the average and the standard deviation, the median, and the IQR. But when you add something or subtract something, it only affects the average and the median. So only the center is affected. So that's what we're going to do. We multiplied the average of 4.23 minutes for the songs times 60 to convert it to seconds, and then we added 5 towards the end. Therefore, we got 258.8 seconds. The standard deviation is only affected by multiplying and not by adding the 5. Therefore, you convert the 1.38 minutes times 60, and you get 82.8 seconds for the standard deviation. Now, the last question, it says, what are the mean and standard deviation? Basically, it's asking, hey, when you have an average, what is its z-score? And if you take it through the process, You take the average minus the average divided by standard deviation, you'll get 0 over 1.38, which is just 0. And what that's trying to tell you is this. When you have a normal graph, your z-score is going to be 0, which, again, like we've talked about in class, is the same as your x-bar. Then you have one standard deviation. So your standard deviation is going to stay the same. So if you have a standard deviation of 1.38, well, that's going to be a standard deviation of 1. So basically, when you draw the graph, what that's going to look like is this. If you have two graphs, okay, if this is your x-bar, and then your first standard deviation is 1.38, what it wants to know is, what does it look like when you convert them to the z-scores? So here's my z-scores. The average would now be a 0. The standard deviation will now be 1. So these are your observations. These are your z-scores. And that's really what it's asking for on that last one. So if you'll take a look at it, let me go ahead and delete all these. I'll pull this down, and that's what that last question is asking.